Dear conference participants, this report is dedicated to energy consumption optimization in heterogeneous HPC systems with FPGA accelerators. Today's large-scale computing systems such as data centers and high-performance computing clusters are severely limited by power and cooling costs for extremely large-scale or exascale computing problems. The steady increase in electricity consumption is a growing concern for several reasons, such as cost, reliability, scalability, and environmental impact. At the same time, numbers of scientific papers on energy-aware optimizations for HPC systems with FPGA controllers are extremely low compared to all researches about FPGA heterogeneous computing systems. As you can see on figure on the slide, which indicates a limited number of solutions in this domain. So this work will be focused on heterogeneous application of energy-aware optimization in FPGA-based HPC systems. Present day, there are a set of methods and approaches to resolve this energy optimization issue, mainly only for homogeneous CPU-based HPC systems. General taxonomy of these techniques suggested and depicted on figure on the slide and can be divided into two main groups. It's SPM or static power management and DPM or dynamic power management. SPM methods divide into separate groups for hardware and software level management, usually defined during design time and cannot be changed in runtime. Hardware SPM techniques can be detailed and split into three separate groups. It's circuit level, logic level, and architecture level. DPM methods, widely used in HPC systems, can be divided into two main groups. It's a DCD or dynamic component activation based on predictive and heuristic approaches, and DPS or dynamic power scaling, like resource sorting and DVFS or dynamic voltage frequency scaling. These techniques can be foundation for more complicated optimization methods, an example task scheduling based on DVFS or DCD heuristic applications. Methods described before can be used on different hardware platforms, both homogeneous, which are well studied nowadays, and heterogeneous based on GPU, TPU, FPGA, CGRA, and other accelerators, which became popular in HPC today. In the introduction section, I mentioned that optimization techniques can be divided into hardware and software types. First of them are case-specific for different variation of hardware like CPU, memory chips, network cards, and etc. While software-defined approaches can be generalized and provide solution for disparate equipment with the same characteristics or types. An example, homogeneous or heterogeneous GPU and TPU-based HPC clusters. Such software solutions are often leads to energy-efficient task scaling methods, optimization problem of which can be defined in the next way. For two tasks X and Y from a set of job pairs D, where D is a set of devices which can be assigned for job J in the set J. Time of communication between these jobs obtained from function com. Then the solution for scheduling problem is a set of assignments A and start times for each job, like described in equation 1.3 with optimization condition in equation 4. This method involves enumeration of all jobs of all available resources, which leads to the idea that the solution can be found in polynomial time. And it was proved that problem of energy efficient active time scheduling is NP-complete. So to be able to use this model, there can be two possible ways. It's a use predefined constraints and pre-calculated configurations, or use heuristic methods, an example generic algorithms to find solution during runtime. General optimization problem was described in previous section, and to be used in a real HPC system, it requires properly defined optimization criteria. Existing solution in this domain based on energy consumption metric or EC, or can be take under consideration as properties, in example, execution time or etc. Power consumption can be described via energy itself in joules or watts, or can be represented with more complicated models like instruction per joule or per watt. Most sophisticated approaches can use a combination of following metrics such as energy consumption, execution time, AST, AFT, and etc., which are listed on this slide. Heterogeneous computing in HPC refers to utilization of diverse hardware accelerators, like a general purpose graphic processing unit, GPU, field programmable gate array, FPGA, or coarse-grained reconfigurable array, and specialized coprocessors, alongside with traditional CPU. This approach harnesses the strengths of different computing components to optimize performance and energy efficiency, making it particularly well studied for workflows that can benefit from parallel processing. Most common heterogeneous clusters involve usage of coupled CPU and GPU as a single node. Therefore, nowadays, existing energy efficient solution for this kind of systems. But FPGA, in the same time, in HPC is a new type of accelerators and less studied, as it was shown in introduction. But nowadays, there are existing works on these topics. An example, the technique of cooperative CPU, GPU, and FPGA task execution based on engine cell framework. A new approach called cooperative heterogeneous acceleration with reconfigurable multi-devices. Was also proposed for multi-hybrid accelerator cluster with GPU and FPGA coupling, which was implemented in Alpiero nodes in Silence cluster. Architecture of this nodes shown on figure on the slide. These existing solutions have a lack of energy consumption optimization, and despite existing methods of power management and optimization described in the survey of optimization methods and center efficiency. So, in conclusion, I could say that this work shows modern theories and approaches for power consumption planning and optimization for heterogeneous HPC systems, including the optimization model for MPP system described in paper for this work. As this problem is incomplete, heuristic approaches for finding solution can be used. Result from mentioned solution can be implemented on hardware or software level via DPM technologies. At the same time, mentioned solution is well suited only to CPU, GPU coupled system, but not for CPU, GPU, FPGA coupled systems. For the last one, there is existing power management techniques like easy to use FPGA TCD, but there is a lack of schedulers and general approaches for implementing solution from theoretical optimal model. Therefore, future work involves further search ways of amplification methods, including heuristic solution of power consumption planning in FPGA coupled HPC systems. And that, thank you for your attention.